So today I'll cover some new topic, right? And these are called, here we have the agenda, right? The mixing of objects. That means if you're combining two and more than two objects that of a different data type, right? So how this basically accommodate, okay? And then we'll move to the explicit coercion, where we'll use some function, for example, print function or as.numeric, as.character to convert from numeric data to a character data, right? Then we'll cover the matrices. Matrices are basically two-dimensional way of storing the data. Okay, but matrix can only hold same kinds of data type, right? It cannot hold two or more than two data type together, right? So this is the problem with the matrices. I'll show you the structure. So we study in the school, right? So matrix has rows as well as the columns, right? And that's why we call two-dimensional way of storing the data, right? Vector is one-dimensional way. Similarly, we have some higher concept that is called arrays. So arrays can be any dimension. It can have a n dimension, right? So this is the way. Then I'll show you the list. Lists are a special type of object in R that can store a different type of data. Okay, it can hold numeric data, character data, list, logical data type, and also the complex. Okay, it can hold all type of data type. Then I'll show you the factors. So R basically treats character data in a different way. So it basically creates a dummy variable in the form of 0, 1, 2, and so on, right? And then it processes in that fashion in the model, and then it'll provide the result, right, in the form of 1, 2, 3. Okay, the ordering order. Right, so that's why we'll have to be very careful about how it converts, okay, and how it basically changes from a character data, right, to a numeric one. So we'll have to have some certain structure, okay, and accordingly it basically converts. I'll show you that. Then I'll show you how to identify the missing values. So missing values are NA, right, in R. It basically has numeric NAs as well as the character NAs. I'll show you how to identify and how to resolve that. Then I'll show you the very important concept that is called data frames. This is nothing but the tabular representation of data, right? And the benefit with the data frame is you can process the data very easily and efficiently as compared to the old structure, for example, list, vector, and other things. And then I'll show you the attributes of a data frame. That is, means you can extract the variables names or column names or names, right? So these are the same thing. And then we'll have a question answer session at the very end. Okay. So let me open the RStudio. So first of all, I'll just clean this whole thing, and then I'll set the working directory here. So this is the location I'll have to change based on the current patch. It is D drive, R training, September, right? So I can change this working directory location, and I'll have to make this /double. And that's also, I set the working directory. This is okay. Why? Because I don't want to store everything in a C drive. That's why I set it in a D drive. This is recommendations, right? Because we don't want to fill all the spaces in a C drive, right? Because all the software originally stored in and generally installed in C drive, right? So that's why it is a recommendations. Try to set your working directory some other drive. Okay, if you don't have, maybe you can do the partitions. Because that is a very easy and efficient way, okay, because it don't fill the spaces in a C drive. Okay, the next thing is I'll just check, right, this is set, right, so that's why here we have the location, okay, the same location that I set here. Okay, that's all. The next part is the main topic, the mixing of objects. So mixing of objects means, here if you notice, I'm just creating a vector x where I have two values. One is 1.7 and second is alphabets A, right? And if you notice, this first value is a numeric values and the second is character. So whenever we have such kinds of structure, right, what this does, it will do an implicit coercion, right? So that means it try to accommodate the object in such a way that there should not be any loss of information. Okay, so what this does, there is no possible way. We cannot convert this alphabets A into a number. There is only one way, that is just to convert 1.7 into a character data. Okay, and it does the same thing. So if I run this and if I print this thing here, if you notice, just converted 1.7 to a character data. And here, if you notice, I have not used any explicit function, for example, as.numeric, as.character, right, for converting to a character or numeric data type. Okay, it is doing implicitly. So that is called implicit coercion. Let me show you the structure. So if I show you the structure, this is character, char, right? It is very clear from here, right? The values are stored inside the code. That means this is a character vector. We can also print explicitly using the print function, and here is the result. Okay, so this is one example. When we combine or coerce a numeric data with the character, it always converts the whole thing into a character data type. This is a rule. Okay, but what about the other objects? For example, here, so here I'm combining a logical data type with a number. So R basically stores the logical data type that is true as 1 and false as 0. Okay, so this is the structure, right? How it stores internally. So when I combine a logical data type with the number, it basically converts the logical data type, for example, true as 1 and false as 0, and it stores as a numeric data as a whole, right? So for example, if I run this y, and if I print here, so you can notice y is num, okay, where we have two values. First value is 0. Why? Because I store here false. Okay, so that's why we have 0. The second value is 2 as it is. And now I can print. You can check the structure. This is num. Similarly, we can combine the true and 4 together. And here also we have the same thing, right? So basically it stores true as 1. So that's why we have 1 here at the first position and 4 at the end. If I check the structure, this is again num. Okay. What if I combine the logical operator or logical data type with the character, right? So again, there is no way just to convert this alphabets into a logical data type. So there is only one possible route, and that is just convert this logical data type into a character data. Okay, and here we have so a and true, and you can check the structure as well. And then yeah, so here this is again our character data. Okay, so this is the way. So when different objects are mixed, okay, so what this does, it basically coercion occurs, right? So that every element in the vector is of the same class, right? So this is called implicit coercion. It's try to accommodate everything, right, without losing any kinds of information or precision. Okay, and these are the possible scenario and possible way how it accommodate. Okay, and because here we are not using any kinds of functions, that's why this is called implicit coercion. I'll show you the explicit coercion, where we write some function just to convert from one data type to another data type. Okay, similarly in SAS, right, we use input to convert anything that is stored, any number that is stored as a numeric data, as a character data, to a numeric, right? Similarly, we can do put to convert back to a character data type. Okay, so these are the things. And here we have length function. It can basically extract how many elements we have in a particular object. Yesterday I showed this. Okay, here we have a bunch of other example, right? So let me show you. So when I combine this 2, false and 3, so it will basically convert true as 1, false as 0, and then we have 3 at the end. Okay, so you can notice this z is a numeric data, right? This is number, so you can do very easily mathematical operation. We can multiply, add, subtract, whatever, right? And here we have the result. Okay, similarly we can store a single values here, num. Okay, and we can check for a particular thing. For example, here if you notice, z is having a single values, so I can check whether this z is a vector or character or a number or logical. So we have a function, a generic function is is.data type. So you can use is.vector for checking a particular object, right? For a vector, you can use is.character for checking a particular object, right? For the character, similarly for numeric and logical. Yeah, so what you can do, you can just remember is.data type. I guess we should have somewhere. Okay, now let me type here. So I don't remember this whole thing, you just remember this part, is.data type. as a general formula. Yeah, it will look for, check for a particular. Yeah. So let me run this one by one. So is that vector true? This is correct because Z is a vector, right? If we store any objects in R, right, whether it is single objects, single values, right, single values object or multiple values object, all are in a vector data type. Similarly, we can check a character. So if you notice this Z, this is number, right? This is not character, so it should give a false as our answer, right? Notice this is the thing. You can check this numeric, this should give true. Logical, it should give a false. So this is not logical data type. Okay, so any question on this implicit coercion? I'll pause here. Anybody, anything?
So Ranjan,
Yeah, please.
so first you assign 103 and then you multiplied, right?
Correct.
Multiplied, and then you implicitly assign just one
So
instead of.
yeah, so here because we are doing practice, right? So that's why I use same objects name again and again, right? Because I don't want to create here a whole lot of objects. So that is the intention, right? But I recommend here in the real programming, and when I do a part 2, I'll not follow that structure, right? Because if you do that, it will basically replace the previous data, right? And it will basically override the previous one, right? So that should not. Yeah, this is not a recommendation. This is not ideal because here we are doing practice, so we can do that because I don't want to create a whole lot of things here in the global environment.
Okay, so just for our understanding, you just assigned Z equal to 1.
Correct.
And then you're checking. So
Yeah.
Last run will be assigned to Z.
Correct. So whatever the thing, if you are doing multiple assignment, it will basically keep the latest one or a last code or last row.
Okay.
It will do the override on the previous one. Okay. Yeah. Anybody? Anything?
So first vector of Z is.
Yeah, please.
So it is showing as true.
Correct. So because this is a vector, because if we store a single element also, it'll have a vector as a structure, right? Whether it is a single or double, whatever thing that you store, right? It follow the vector structure. That's why it is given true here in the first place.
Okay,
that's
then
that's why I intentionally use single element, because in the case of more than one element, it is giving here a big bracket, right? This is the indication that this is a vector, right? But in case of single, it is not giving any kinds of big bracket and the values inside, right? So that's why I just use this explicit, because you can very easily check here. This is very clear, right? Because we have more than one element, right? So anybody can understand that this is a vector, right? But this is the main part. Yeah.
How about the character of Z and then the numeric of Z? Why it is false?
Character. So this is not a character data. Here I am storing a number, right? So it should not be a character. Okay. And for the logical, this is also not a logical data type. This is a numeric data. That's why it is giving true here in the case of numeric. Okay. And it's giving in the false because this is not logical. This is again not a character. That's why it is giving false.
Okay. Yeah, got it.
On the other hand, if I just change that to, if I add a quotation, that means we converted this into a character data, right? Yeah. If you notice here, it is giving CHAR. This is a short notation for a character. And in that case, it'll give a vector as true. Yeah. Character as true, numeric false, and logical false. Right. So it depends solely on the element what you're defining. Okay.
Okay.
Yeah. Okay. Any follow-up question? Anybody?
Hi, Ranjit.
Yeah, please. Hello.
Mixed. Am I audible?
Yeah, I can hear you. Please go ahead.
In in mixed vector, let us z equals to 1.7 and a was there. So when we executed that one,
Correct.
so it read like implicit correction happened and it is reading like a character.
Correct.
1.7 is reading like character, right?
Correct. Yeah. So both are because
Now when in our last execution, we are checking is dot using the is dot numeric is dot character.
Correct.
There it is popping up like numeric is true. So now it is reading in numeric, right? Like our programming it in numeric, right?
Here I just define as z as an additional thing, right? So that's why it is basically working based on this, right? So let me just define here once again. Okay, what I can just clean. I'm just defining in the console, right? So it's basically I'll not save, right? Because we already have here multiple examples. So let me just define. So I'm defining char, and here I'm storing values 1.7, right? This is the first value, and I'm adding one more, right? So I'm adding one values as alphabets. Maybe I can just remove that quotation. Yeah, I can use 1.7. This is the first value. Second value I'm just giving as capital letter A, right? So what this does, it will basically try to accommodate the values, right, without losing precision, right? So there is no way to convert this alphabets into numeric data. So there is only one way, and that is 1.7. It will convert 1.7, right? That is given as numeric values into a character data type, right? So when I run this and when I print this char, it should have a character structure. And that's why we have 1.7 right inside the quotation. In the beginning, I have not given here a quotation. So this is because of implicit coercion, right? You can check the data type. If I use str of char, it should give a character data. Yeah, you can check is.vector. So because this is a vector element. Why? Because here we have more than one, right? In case of one also, it should give a true, because this is an inherent structure of R. If you create anything in R, it must have a vector structure, right? So if I check is.vector and if I pass here a char vector, so it should give true, right? You can check is.character. Why it will give true? Because here also is.character it will give true. Why? Because this is a character data, right? Here also it is have indications, right? So let me verify that explicitly. So it will give true. On the other hand, if I use is.numeric, because this is not a numeric data, so in that case it will give a false, right? On the other hand, if I check is.logical, again it will give false. Yeah. Similarly, we can check other thing, is.complex. Yeah, because yesterday I just discussed these kinds of data type, right? A vector, character, numeric, logical. Okay.
Yes, correct, Ranjit. Everything that we have done right now, it is reading, if it is a character, it is reading like a character.
Correct.
Here we have given numeric z equals to 1, then it is reading numeric. That point is clear.
Correct.
But it is reading there like okay, sorry. Maybe I'm not putting my question clear.
No worries. Yeah. We can try once again. No worries. Yeah, don't hesitate. Please go ahead.
No, here 1.7a, even though you are not giving in double quotation character,
yeah,
is reading like numeric.
Not
sorry, character.
Yeah, reading character. Yeah, correct.
And it is dot is giving character. Data type is character.
Correct.
But whereas in the following up, z.
Yeah,
you have given
here because I have a single element, right? So that's why it basically tried to accommodate the structure that we provided, right? Here we don't have any other thing, right? Right?
Okay.
Here we don't have any other maybe alphabets, right? So that is the
okay. So mixed data type, then it will.
Yeah, in case of mixing objects, in case of mixing data type, in case of data type that is of different kinds, it try to do a coercion, right? Kind of converting back to maybe in such a way that it should preserve all the informations without losing any precision, right? Because in case of single, it should not do any kinds of conversion. This is the main.
Okay. Thank you.
No, it's okay. It's okay. Don't hesitate. Yeah. Okay. Anybody? Any follow-up question? Towards anything? Okay. So now I'll cover the explicit coercion. Explicit coercion is very easy. Here we generally use some explicit function for converting back from one data type to another data type. Right. This is a simple thing. So let me create here x1. Yeah. Here we have a numeric vector -1, 0, 1 up to 6. Okay, I can check the class. This is a numeric. Similarly, here I'm just creating a x. These are in quotation. That means this should be a character class. Okay, this is character. So what if I want to convert this x into a numeric? So we have a very simple function as.numeric. Yeah, we just have to use this, and we can pass the thing that we want to convert into a numeric data type. Right here, we don't have to specify base dot anything. Right, it will basically converts. And here we have the result 1, 12, 13 and 17. So if you have numeric, you can do any kinds of numerical evaluation. You can evaluate the mean, median, mode, whatever, and other summary statistics. Okay, that's why converting back to a numeric is very important, because sometimes we need to evaluate the summary result for a data type. Now, and here, if you notice, I just gave a variable name right after converting this back to a numeric data. I gave here a name x_now. So I can check the class of this. It should be a numeric class, right? Similarly, here x1, I define x1 as a numeric vector. So if I use as.logical, what this does, it will try to convert right to a logical data type in the form of true and false. And what this does, it will assign 0 to false, and all other values except 0 it will assign as true. So you can notice I'll just first print the x1 so that you can compare. So in x1 we have first value as -1, second value 0, and all values 1, 2, 3 up to 6. If you notice here, what this does, as.logical, it basically converted this 0 as false, right, and all other values, whether it is negative or positive, right, converted here in the as true. Okay, and here is the answer. So we'll have to remember, right, if you use as.logical, what this does is it will only convert 0 as false and all other values as true. Okay, whether it is positive or negative. Similarly, we can convert anything to a character data type, right, using as.character function. Okay, so here we have x_num 1, 12, 13 and 17. This is in number, right? You can use as.character and you can convert to a character data type. Yeah, so let me run this, and if you notice, now we have a quotation, right? The values are stored inside the quotation. That means this is a character data. Okay, and you can very easily use class statement here just to verify that. Okay. Yeah.
Ranjit, we can also use str, right?
Yeah.
Instead of class.
Use str. Yeah.
Both are same.
Yeah.
Okay.
Yeah. So a speciality of str, if you use str, it will also give the values, right, along with the data type. So here, if I use x_ch here, yeah, here we have the data type along with the values. Okay, so similarly, we can convert to a complex. For converting complex, the input should be a numeric, right? This is very important. Similarly, for converting logical, the input must be a numeric data. Otherwise, it will not work, right? So let me just write here. Okay, I can write here. Yeah, here I also already wrote, right? So numeric data type to complex data type. So input must be of numeric. Okay, so what we have to remember, you just have to remember as dot data type, right? Just to convert from one data type to another data type. Okay, so let me give absurd example here. So I'm just storing here x, where we have alphabets A, B, C. I'm just printing, right? And now I'll show you the function, and these are the function that we should not use, right? So here we have alphabets, so we cannot convert to a numeric, right? So that's why I just want to make you aware, right, that these are the functions we should not use. So if you use as.numeric, what this does, it basically provides NAs, right, because there is no way converting this alphabets into numeric data, right? And here is give a warning. So warning introduced, NA introduced by coercion, because I'm not able to convert this alphabets into numeric. Again, if I use as.complex, I already told for the logical data type, we must have numeric input. So if I use as.logical, again give NA. If I use as.complex, again give NAs, right, and the warning at the same time. Okay, so these are the way of explicit coercion, right? So I'll pause here. Any question? Anybody?
Hi Ranjit, if there are anything like a missing values, how it will handle?
Yeah, I'll cover that part. We have that thing at the end. Okay.
Right. In the starting, to convert into the numerical values, character to the numeric, as.numeric we have used.
Correct. Yeah, correct here.
So I didn't understand this one. So here the variable x is, representing 1, 12, 13 and 17. So this is a numeric, right? So numeric values.
No. This is in quotation, right? Within the quotation, the values are stored within the quotation. That means these are the character data, right? Let me cover that. I already run and check the class, right? This is character.
Okay.
Yeah.
Oh.
Yeah, and also there is no way. For example, here these are also character, but we cannot convert to a numeric. Why? Because there is no way we can convert these alphabets into numeric. But here these values are stored as characters, so we can very easily convert. Because although the maybe the core values, right, are numeric, we can very easily convert to a character to a numeric data type. Okay, I'll cover that. That's checking for missing values in a minute. Any follow-up question? Anybody? Okay. So the next part is here the matrix. Matrices are basically a two-way of representing the data, right? It must have a rows as well as the column. So let me just open some document and then I'll show you. Yeah, so this is you can think of matrix as, let me change the color. Yeah, so you can think of matrix as two-dimensional. So this is dimension 1, right? dim1, right? And here these are called rows basically, right? And these are called columns. But the speciality of matrix is it can only hold a same kinds of data, right? So, and here we have different cells, right? We can have different cells, right? These cells basically store different values. Okay, so for example, here you can think of this is row number 1, row number 2, row number 3, then 4, right? Then column number 1, column number 2, column number 3, column number 4, right? And these individual cells basically holds the values, right? And all the cells, whatever we have, must have a same kinds of data type. So you can have either numeric matrix, you can have either character matrix, you can have logical matrix, you can have a complex matrix, right? Where we have all the data values, right? All the values we have here must have the same data type. You cannot mix these two things together. If you mix, it will basically try to accommodate in such a way that it basically preserve all the information. So it do the coercion basically internally, right? And it try to accommodate all the values. But at the end, it must store each and every values right in the same data type. Okay, so this is the thing. So let me show you how to create the matrix. So we have here the function matrix. You can use that, matrix, and then here you'll have to provide the data. Okay, so here I'm just providing the values 1 colon 9. That means it will basically giving here 9 values, and then I'll have to provide here the attributes, so number of columns and number of rows. And we must have, we should be very careful here that whatever the values that we're providing must be of multiple of number of rows and number of column that we are specifying here. So we are specifying 3 rows, 3 column, that is 3 into 3, that is total 9. And here we are giving also the 9 values. So try to accommodate in a better way, right? And try to fill all the available cells. So 3 rows, 3 column means, let me draw another thing. So I can segregate this box into 3 column. This is column number 1, column number 2. Sorry, I'm writing with the mouse, that's why. Very terrible writing. Yeah, so these are the columns. Then I can segregate in 3 parts, and these are our rows. So this is row number 1, row number 2, and row number 3. Yeah, so here I can fill the values. So it can fill the values 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? So the number of rows, n rows, I specified in the formula as 3, n col is equal to 3, and I gave it here data as 1 colon 9. So that's why, because if you multiply these two, right, 3 into 3, that is 9, and that's why I must have to give here 9 values. If we give more or less, it will basically fill, right, in such a way that it must accommodate all the values. So I'll show you that example. So first of all, we have a very simple one, and if you notice here one pattern, so I fill the values in a column wise fashion. So what this means, it will first fill the first column 1, 2, 3. Then after completion of the column number 1, it moves to a column number 2. Here it'll try to fill the second column 4, 5, 6. Then it'll move to the third column 7, 8, 9. And this is the way how it fills as a default. You have a way of changing that. You can fill a row wise fashion. That means, let me write here another matrix. Sorry, let me go down. Okay, I can insert a new page. Yeah, so we can insert, and I can show you one structure. Yeah, so again, I can write col 1. So let me just write there also with a different color so that we can understand, right? Or maybe I can create, because I don't want to mess up. Yeah, so col 1, col 2, col 3, then row 1, row 2, and row 3. So here we'll have values 1, 2, 3, 4, 5, 6, 7, 8, 9. And there is no hard and fast rule. We can give any values, right? But it must, the value that we are providing must be a multiple of the number of columns and number of rows that we are specifying for a matrix, right? This is very important rule. Yeah, and this is called row wise filling of values. Let me write next.
So where do we use specifically this concept?
Yeah, so we'll use this concept in matrix algebra, right? And because we are covering each and every aspect, that's why I just want to cover, right? This is also important because sometimes we need to store two-dimensional data. In the clinical trial settings, we try to use a data frame structure more, not use a matrix anymore, right? But these are useful concepts. That's why I'm covering here as maybe a building block. Okay.
Okay.
Yeah. So here I just gave 1 colon 9 as a data. If I run this, the selected part, right, it will basically create values from 1 to 9. This is the input. Then I'm specifying n row is equal to 3, n col is equal to 3, and I'm specifying here by row is equal to false. That means by default, it fills the values in a column-wise fashion. What this means, let me run and show you. You notice it is filling the values. It is first accommodating the column number 1. This is column number 1, then column number 2, 3. Right here we have row number 1, row number 2, and row number 3. And if you observe here the data, how it is basically filled. So it is first, right, accommodated the column number 1, 1 to 3. Then after that, it will move to a column number 2, 4, 5, 6. Then it will move to a column number 3, 7, 8, 9. Okay, so this is structure. If you want to fill in a row-wise fashion, that means 1, 2, 3, right? 1, 2, 3, then 4, 5, 6, 7, 8, 9. What you can do? You can just specify by row is equal to 2. So by row means you are giving an instruction, right, to fill the values in a row-wise fashion. This is a simple thing. Okay, the next part is we can also extract the dimension, the number of rows and number of columns, right? So using the dim function, yeah, it will give 3 and 3. The first value corresponds to row and the second values is for the column. You can also run the attribute function. I'll give, right? So here I have not specified the name for the columns and name for the rows. We just have number, right? So that's why it is not giving any additional information other than just dimension. But I'll show you at the very end, right, when I specify the names for the rows and column, right? So in that case, the attribute function gives a whole lot of information, right? I'll just revisit that thing in the bottom. Okay, so let me just fill the values in a row-wise fashion. I just specifying this by row is equal to true. Yeah, and here we have. So you can notice the difference in the previous matrix, right? Matrix M. We have the filling of values in the column-wise fashion, 1, 2, 3, then 4, 5, 6, then 7, 8, 9. But here we have a rows-wise filling, right? 1, 2, 3. It will first complete the row number 1. After that, it will move to the row number 2, then row number 3. Okay, so this is the thing. And now I can print, yeah, and I can create a vector M1. Yeah, so I'll just use this M1 later, right? So this M1 is nothing but the numeric data, integer values, right? You can check the class of this, right? You can also check the class of M1. This is integer. You can use this is.integer on M1, so it'll give true. You can check is.character. This M1 is not a character. This is a numeric vector, so this is false. On the other hand, you can also apply all the functions here on this matrix M1, right? So let me run this again, so you can check M1. So it will give again, yeah, so this is also because the values inside whatever value we have, these are integer. That's why it is giving M1 as integer. You can check the class. Yeah, this is matrix and array. Array is maybe some kinds of higher dimensions, right? So inside the array, we have matrices, we have other dimensions of array, right? So arrays is a parent structure, right? You can think of. Okay. So similarly, we have a function is.matrix. You can very easily check, right, whether a particular object is matrix or not, right? These are explicit way of checking a certain thing, right? So if you notice, I define here M at the very beginning, right, at line number 78 as a matrix. That's why it is giving true. Okay. Similarly, yeah, so you can just extract the part of that. Yeah. Sorry.
I have a question. So, I mean, like this matrix syntax is a little bit. I mean, like first time when we see.
Correct.
So
yeah,
can we
have to do a practice for that? Yeah.
Yeah. Can we use like a question mark or help matrix.
You can use any time, right, for any functions. So here you can just write where it is. So let me show you. So you can use question mark matrix. It will give here the syntax. Data, then row, call by rows, team names, right? We can do that. And at the very end, we'll have example. So this is the way you can use any functions. For any function, you can invoke the help, right? And you can extract the commands, right?
Okay. Yeah, got it.
Sir, I have one question.
Please.
Sir, in this structure is showing integer. Why it's showing integer?
Because
like we are not passing L.
Because here the input that you are passing, this is integer.
Mm-hmm.
That is the main part. Okay, this matrix is of integer data. Okay, so that's why it is giving here int as a structure. But the class.
Why it's not showing num? Okay.
Num, because this does not have a numeric values, right? So when I use this one column 9, when I use column function, it always create a integer data, right? Not the numeric data. Okay. It basically doesn't holds a decimal component, right? This is again a part of a numeric data anyhow, right? Anyway, but this does not have a numeric component. That's why it is not giving numeric here. It is giving integer. Why? Because these are the integral values. We don't have the decimal component here.
Right. Thank you.
Perfect. Anybody? Any follow-up question? Okay, now I'll move to here. Okay, so we can also do a subsetting, right? I'll show you that later. We can extract the dimension, right? It will with the dim function, it will first extract the rows, and the second value is for the column. Then we can also extract the dimension of M1, right? And then we have two built-in function, right? Letters in lowercase and letters in uppercase. This basically have the alphabets stored in upper and lowercase, right, respectively. So you can check here. And now I'll use these two function, right, to build up a character matrix. So right now the M and M1, what I showed, right, this is for numeric data. Now I'll just use this character values, right, for creating the matrix. So here, if you notice what I'm doing, I'm just extracting the first 9 alphabets from this letter, and then I'm just arranging in a matrix notation. So 3 rows and 3 columns. And I'm also giving here by row is equal to 2, so it will basically fill in a row-wise fashion. So A, B, C, then D, E, F, and then G, H, I. Right, this is a row-wise structure. Similarly here, I can also use this lowercase, right, and you can arrange in a row-wise fashion. So here I just use by row is equal to false. That means it will basically fill in a column-wise fashion. Okay, and also here, if you notice, I have not used explicit argument. N rows is equal to 3, n col is equal to 3. So by default, it just take the first values for the number of rows and second values for the number of columns. And this is the thing. Similarly, I'll cover here a few other structures. So let me just create 2 individual vector x and y. This is having a length 3, right? Let me just make here also a 3 element, right? Let me use 12. So we both have 3 values, 3 element. I can use a combined, right? So you can use C bind, that is called column wise combining of a data, right? Column wise combining of a vector. And you can also have R bind, that is called row wise combining. So column wise combining means it is similar to merge, but not exactly the merge, because in the case of merging, we'll have to specify some by variable or some common variable or key variable. But here I are not specifying any key variable or by variable. So what this does, it will basically try to accommodate the other vector, right, as an additional column, right? So for example, if I use C bind x comma y, so let me run this and show you the structures. What this does, it will first store here the x, right, where we have 1, 2, 3, and it try to accommodate y just beside that, right? And here we have the values. So this is called a column wise combining. So basically it is creating additional column for the y and try to accommodate. And here we must have the same number of data type, same number of values in both the vector. If you don't have, it will give you an error message. So how you can resolve? You just have to use some higher structure, deploy structure. I'll show you later. Or you can fill the you can fill, or you can try to accommodate the equal number of values just utilizing the NAs, right? For example, here in the X we have just 3 values and Y have 4 values. So what I can do, I can add NAs here at the very end just to make here a 4 data, right? And you can do combine R bind or a C bind. So C bind is a column wise combining of data. Similarly, the R bind is basically a kind of setting or appending of data. Right? So let me run this R bind also. Yeah, so it will basically have 1, 2, 3, right? This is X, and then 10, 11, 12. Here also we must have a same number of element. And why I'm covering this C bind and R bind? Because it gives a flavor of a matrix arrangement, right? So this is one thing. Yeah. And then here we can create a matrix of different dimension, right? So I have here 2 rows, 5 columns, right? And here we must have to give here input, right, as a multiple of these number of rows and number of columns. So 5 into 2, that is 10. That's why here we'll have to provide 10 values. And you can use here any values, right? There should not be any right? This values should not be maybe a continuum, right? You can use any values. You can use decimal. You can use integer, right? Anything, but the values must have the same data type. Okay, you can also create. So this is 2 rows. Row number 1. This is row number 1. This is row number 2. And here we have 5 column. Column 1, column 2, column 3, column 4, and column 5. Similarly, we can create 5 rows and 2 columns. This is just a different structure. Yeah, here we have 2 rows, 2 column 1 and column 2, and then we have here 5 rows. Okay, so here we have a complete multiples. That's why all the values are right exhausted. But for example, here if you notice, I'm just giving 10 values, 1 column 10. But in the row specification, I'm just giving 3, and call specification, I'm giving 4. So if you multiply 4 and 3, you must have to give here 12 values. But instead of giving 12, I'm just giving 10. So what this does, it'll try to fill the values from the beginning, right? After completion of 10, right? It'll fill from the beginning. And at the same time, it also gives a warning. So it will give a warning. This is not a sub multiple of the number of rows and number of columns. Okay. And if you notice, by default, it fills the values in a column wise fashion because I use by row is equal to false. This is okay. Yeah, so it fill 1, 2, 3, then 4, 5, 6, then 7, 8, 9, and 10. Right after completion, it'll start filling the values from the beginning, and that's why we have 1 and 2. Why this does? Because we have specified here n row is equal to 3 and n col is equal to 4. Okay, so that's why I try to accommodate all the cells, right? 3 rows and 4 columns. If you don't want to fill these values, what we can do, we can give additional values as a null, right? And it will try to add NAs at the very end. Or you can give the actual values that you want to do. But this is the explicit thing. And we can give any values. So here, if you notice, I'm giving 9 values. Yeah. And I'm just giving 3 rows and 3 call, right, as a structure. So you can fill here in this way. Okay, so this is the way how we can create the matrix. Any question on this matrix creation? Okay, so let me,
Sir,
yeah, please.
sir, I have a question.
Sure.
Let's say, sir, we have decimal,
Yeah,
like
we can.
0.2 and all that. Okay.
Yeah,
Then it will give as a num.
Yeah, as a num, right? So you can create matrix. Let me just do that. So I can use a sequence function. Hope you can recall the sequence function. What I want to do, I want to first create a sequence. It may, or maybe I can use explicit values. I don't want to confuse you with this another function. Yeah, so I can give here 9 values. Maybe I can use 1.2, 1.4, sorry, comma, 1.4, and again, comma, 1.3, comma, 1.6, 1.7, 1.9, then 2.1. How many we have? 3, 3, 6, 7. Then 2.2, 8, and 2. Maybe we can create it's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 values. What I can do, I can give 2 rows or 4 columns, right? 4 rows or 2 columns. So let me do that. N row is equal to 4, and col is equal to 2. So 4 into 2, that is 8, and it'll fill. Right, and here we have. Or you can give 2 rows and 4 columns. Yeah, and here we have the values as a decimal. The
And
thing
structure of this.
Yeah, so structure, yeah, if I use a structure of this, str of, so because I'll have to store somewhere, maybe I can use here matrix M. Yeah, num, because the values are numeric with a double precision.
And mixture in case of mixture like integer
You cannot do a mixture. So yeah, you can do a mixture of integer and decimal. So in that case, it will have a num as a structure, because it tried to convert the integer also in with the decimal component. Try to accommodate as some 0 at the end. Okay. Yeah. Okay. Any follow-up question? Anybody?
Ranjit, if you are not assigning to any of the object as for the line like 125, you are directly giving as a matrix and data. How it is stored at the backend? Like,
yeah, it basically not stored anywhere, right? It will not store here. It is just providing the result in the console. So for storing in the global environment, what you have to do, you just have to do assignment. Yeah, you just have to give some object name.
Yeah.
Okay. Any follow-up question? Anything? Anybody? Okay. Now I'll show you the list. Yesterday I gave some exposure of list, right? List is basically a way of storing different type of data type together. This is called heterogeneous objects, right? That can hold a different data type. So here, if you notice, I just define. So for creating list, you have to use this list function, and then here you can specify the values. What I did, I just specify here 1, but the difference is I just also give a name, right, as A. So A is the name and 1 is the value. Whereas here, the second position, I directly give a value. Here I not specify any names. On the other hand, this is a third values, and here I just give true, false, and double A. And if you notice, this true and false, right, is inside the quotation. This is not a logical data type. This is a character basically. And at the very end, I gave here a 1 plus 4i, which is a complex structure. Yeah, and this is the way how it stores. If you notice, at the very beginning, we have a symbol $a. Why? Because I gave here name. Okay, so you can keep name to each compartment. And if you have name, so it is easier to extract a particular object. Otherwise, you'll have to use a double big bracket for extracting a particular element, right? So you can notice, this is basically for a particular compartment, right? So this is compartment number 4, compartment number 3, compartment number 2, right? And here we don't have a double big bracket 1, because this is for compartment number 1, and because of that, because I gave here a name, so that's why it was it is showing with the $ symbol A. Okay. So next part is how to extract the values from the list. So this is very important, and this is slightly complex, right? Why? Because this is with the inherent structure of the list. So if you notice, this is suppose I want to extract this alphabets A, and A is stored at the compartment number 2, right? So what I have to do, I have to use this structure, double big bracket 2 inside. Okay, so I can use first the object name. Object name is X, right? And then I have to use double big bracket and 2 inside. Why 2? Because this A is at the second position. Yeah, so let me run this, and here we have the A. Similarly, suppose I want to extract the third element. Third element is all 3, right? So suppose I want to extract all 3 in one go, right? So what I can do, I can just place here 2 to 3, right? And it will extract true, false, and AA, right? Because at this compartment we have 3 different values, right? True, false, and AA. Suppose I need the explicit, right? Single values, double AA, that is stored at the third position. So what I can do, instead of this double big bracket 3 inside, right, I have to use additional single vector y, single big bracket y, because the thing that we have here is in vector structure, right? And for extracting the values from the vector, we'll have to use single big bracket, right? And then we can specify the placeholder for the values that we want to extract. So I want to extract this double A, so that's why I'm using 3, and here we have. Okay, so this is the way. Similarly, suppose I want to extract this 1, right? So here we have the name, so I just have to use dollar symbol A, and we can very easily extract the 1, right? That is stored with the name. So because sometimes if we have a name, right, for a particular compartment, you just have to specify that, and you can extract very easily. Okay, or you can use the old structure, double big bracket 1, because this A is at the compartment number 1. So you can use this way also, and you can extract. A later session, when I do the profiling of R code, I'll show you which one is efficient, right? You can cross compare. Let me just write here. Yeah, so you can just do a benchmark. Benchmark is a way of, I'll have to store, I guess, install package. Okay, so I install that package. I'll have to load. And now I'll use bench. Then mark, and I can express provide these 2 expressions. So I can use the first expression. Yeah, I can use the second expression as this one. And if I run this, it will basically do a benchmark for us, right? And if you notice here, the second way, right, of extracting is efficient. Why? Because the median time is 200 nanoseconds, but in case of first, it is 500 nanoseconds, right? That means the second way of extracting the things, extracting the values from the list is efficient, right? So you can very easily get an idea which one is recommended, right? So the one that is efficient, right, we should use that. Okay, so you can compare also the other expression, okay, of a similar kind. Then here I just gave again a list, right, with the names. You can create that. Here I just give an example how we can allocate the name instead of this big bracket. You can use double big bracket. You can specify the name for each element, and you can extract these easily, right? So whenever we have names, so this is basically easier way of extracting, right? Because you don't have to use double big bracket. And here these are a way of storing, creating a dummy vector, right? You can create a dummy vector of right, of a different data type. You can specify that. Yesterday I showed, right? And this is very important because sometimes we'll have to store, right, values after doing some kinds of processing of data, right? So in that case, we generally create a dummy vector of different type, yeah, and you can store the values. Okay, the next thing is the NAs, the missing values. So here we have 2 categories of missing values. One is numeric, that is stored with NA, The other is character, that is stored with any right, underscore character underscore, right, or we can have blank as well, right. So let me show you. So for example, here I'm just creating a vector name, right, in uppercase, and I'm giving here two values. One is double A, and the second I'm giving as any underscore character underscore. So this is a way of, yes, please.
Ranjit, yeah, sorry to stop you. When you run the x1 with vector of list length equal to 5, then why the list has all these values, right?
So
then why
so if you use vector notation, it will create a dummy vector for us. Dummy means it will not have any values. So that's why if you notice, we have nulls, right? It will basically create a 5 compartment, 1, 2, 3, 4, 5, and we'll have null here, right, at all the positions. Similarly, if we create a numeric, we'll have zeros. When you create a character dummy vector, it'll have a quotations. When you create complex, it'll have 0 plus I. So this is a way of creating a dummy vector, right? And that does not have any values. So these are basically a way of creating first, right? And then we'll do some kinds of mathematical operation, and you can store those values inside these dummy vectors, right? Yeah.
Okay. Okay, sure.
Hope this makes sense.
Mm-hmm.
Yeah, yesterday I covered, that's why I just moved very fast. Okay. So next is here.
So, these vectors, can we use, I mean, like if we have a missing data and if you want to include some null data, do we use this concept there?
Which concept?
I mean, suppose if we want to include a missing row or missing column.
Yeah, you can create a dummy vector and you can just append or set, right? You can use rbind and you can do that. Yeah.
Okay.
Yeah. Or you can use this way, right, that I'm covering here. Okay. So this is a way of, suppose I don't know the second name. So what I can do, I can store a blank, right, using this any underscore character underscore, right? This is a way of storing character missing values. And if you notice here, we have the values and the NAs. And this NAs, right, here, it'll give the same structure, right, as of numeric, right? But this must have a character data type. Why? Because the other object, right, or the other element, whatever we have here, this is in the quotation. That means this whole thing must be of a character data type. You can check that this is character. Okay. So I already covered this data frame creation. I'll just comment that. Okay. So the next part is factor. How we can create the factor. So for the creation of factor, why factor is useful? Sometimes we need to do a modeling, right? And in that case, R basically treats the character data in a different way. So it must have, it basically converts all the character. For example, here we have two character. One is true, one is yes, and the other is no. Right, so we have just two characters. Similarly, we can have mild, moderate, severe, where we have three characters. So what this does, it basically converts these character values, right, in the form of 0, 1, 2, and so on, right? So it will basically create a numeric ordering, okay, and based on that, it'll do the modeling and then it'll return back to the original format, right? So that's why we have a very clear, right, how we are specifying the values. Okay, because it matter a lot, right? For example, here I'm just specifying these values. Here we have total 5 values. Yes, yes, no, yes, no, right? And here this is storing in the same way. There is no issue. But if you notice the label, right, it is giving no at the first position and yes at the second position. Why? Because it will be try to accommodate the ordering, right, in alphabetical order, right? And no, right, N comes first, right, as compared to Y. So that's why no is here at the first position. But we can change that if you want to specify no as the first position. Why? Because sometimes we'll have to choose yes as a main label and no as a reference. Okay, so that's why we should have a different structure. And for that, you can check that. So here there is one function unclass. So if I run this, it basically provides the values in the form of 1, 2, right? So because it has right, it stores 0 as the first position, right, as a label. So that's why it is allocating 0 as 1, right, and yes as 2. Okay, you can notice this is structure. The first position we have yes, second position yes, that's why we have 2, 2. Third position no, that's why we have here 1. Fourth position yes, that's why here we have 2, and then at the end we have 1. So this is the way, because it accommodated, right, no as first position and yes at the second position. Okay, so when we do the modeling, it try to use no as a main label and yes as a reference. But suppose you want to do in other way, you want to use yes as a main label and no as a reference. So what you have to do, you just have to swap that. And how we can do? Here is the structure. So you'll have to specify the factor, right? You'll have to specify the values here the same way, but you'll have to specify a label explicitly. And whatever the thing that you want to use as a main, you'll have to specify here as a first. Okay, so I'm specifying yes at the first position and no at the second position. So in that case, it will basically allocate 1 for the yes and 2 for the no. Yeah, so let me show you. Yeah, here we have, you can notice the difference at the first position. Earlier we were having no, but now here we have yes. Why? Because I specified the labels explicitly. And if I show you the unclass, yeah, so this has, right, it allocated yes as 1, right, and no as 2. So you can very easily do the modeling, and you can use here yes as a main label and no as a reference. Okay, so hope this makes sense. I'll pause here. Any question?
So, in this, it will work with only with the yes and no, or y or n will also work.
Yeah, y and en, anything you can do that. You can do with other values as well.
Just to show, like, yeah.
Yeah, you can do that. There is no issue.
Okay.
So it works with any character data, right?
So the unclass, what is
So unclass
the
basically reveal, right, the inherent structure, right, how it basically handle at the modeling level, right? So that's why unclass is giving the values in the form of 1 and 2, because this is the inherent structure how it uses the this character data. And you'll have other thing. For example, here we just have 2 different labels or 2 different data. One is yes, the other is no. One is y, the other is n. But we can have many more, right? We can have mild, moderate, severe. You can have multiple classes, but you'll have to specify those here in the same order in the labels. Okay. Anybody, any question, thoughts, anything? Yeah, and here I showed a generic function, how we can check for a specific data type. I already covered at the beginning, right? So maybe you can verify that. You can pass these x, y, or whatever, right? And you can check. The second thing is the missing values, how we can identify. So missing values is denoted by NA or NaN, right? These are for numeric missing values. So NaN is a notation for not a number. Yesterday I showed, right? So anything that is in the form of 0 by 0, it will basically provide as NaN, not a number. And we have these 2 additional functions. is.na is used to test whether a particular object is NA. Similarly, we have a function is.nan. This is used to test for NaN objects, right? And I already covered yesterday. So if we divide 0 by infinity, you'll get 0 here. If we divide infinity by 0, you'll get infinity. And 0 by 0 is same as NA. Okay, you can check the class of all these, right? This is numeric. Why? Because here we can do any kinds of mathematical operation. Okay, so let me do a formal check. Right here I'm creating a vector x, and if you notice at the third position we have NAs, and the x what I specified here is of a character numeric data. This is numeric data. So how we can identify that NA? We have a function is.na, and what this does, it will basically provide a result in terms of a logical vector. So it will provide the result in form of true, false, right? So it will provide a true for the NAs, right, and it will provide false for all other values that is not NA. So let me run this. So here it is giving here a string of true and false. So we have false at the first and second position, true at the third position. Why? Because we have the NA as the third position, and then again fourth and fifth is again a false. Okay, you can also use is.nan. Yeah, and here if you notice, this function is not able to identify or detect this NA. So that's why we don't have true at any position. It is just having false. Okay, so this is the way. But I'll show you how to. So this function only detects or only identify the NAN structure, right? So let me create another matrix, another vector X, and here we have two things. One is NAN at the third position, and we have NAs at the NAN at the third position and NA at the fourth position, right? So let me check the class. This is again numeric. If I run is.na function, so the benefit of using this is.na function, it can detect both things, right? It can detect NA and also the NAN. Okay, so if I run this, I'll give a true for this NAN, right? That's why we have true at the third position, and it also detects the NA. That's why we have true at the fourth position, right? Whereas is.nan, it cannot detect, right? It can only detect the NAN, so it only give the true for this third one, right? It will not give a true for the NA, right? So let me run and show you. You can notice it is just giving a single true, and true is only at the third position. That means it is only able to identify or detect this NAN, right? And this is a way of identifying the NAs. Okay, so any question, anybody? And this is at the very basic level. I'll later show you how to identify, right, using the same function, how to do the imputations. So our first part is just to identifying the NAs, and if we have multiple missing values in the data, right, what we do, we'll do the imputation. Why? Because if we don't have a sufficient data, all the statistical measure fails because of insufficient power. Okay, so that's why we try to do the imputation. All the statistical maybe bias test or stat person basically do the imputations, right, just to make the study, right, with the sufficient power. Okay, so we'll do that imputation, I guess, maybe later, right? We don't have here, so we'll do in the upcoming session. Okay, so any question on this identifying of missing values? We're getting echo. Okay, anybody? Any question, thoughts?
None means
Yes, Padma.
NA means none means NAN.
Sorry?
NAN means
NAN is here. I just already mentioned. NAN is not a number. So whenever
not a number.
Not a number. Whenever we have something, right, some mathematical expression in the form of 0 by 0. In calculus, we call this as indeterminate form, right? That means we cannot evaluate that thing further, right? So if we have that structure in R, right, so it will give NAN as a structure. And we can also have a function to maybe identify or detect that thing, right? And that function is this one, is.nan. Okay. Any question, anybody? Okay, now I'll move to the data frame. No question? Anivita, I guess your mic is open. Anything from your side?
Yeah, Ranjit, I have a question. Like
Please.
these NA is to detect only the missing values, right?
Correct.
Okay, so okay, fine. I'll come with the question.
Yeah. So is.na can detect nan, not a number, and also but nan is also sometimes, right, in a very loose way, right? We treat that as a missing values, right? But exactly in the conceptual way, right? That is not a missing value. That is maybe some kinds of situation where we have a 0 by 0, right? Where we have a denominator and numerator, right? Both are 0. That is the case, but in a loose term, we treat that also as a missing. Okay, that's why I'm just covering these two in the same way.
Sir, in case of character missing value, then also we use this.
We can use the same structure for identifying that. Yeah, and for storing, you will have to use different. You'll have to use either a space or you'll have to use any underscore character underscore. Yeah. I guess somebody's also have. Yeah, please.
Ranjit. So instead of NaN and NA, I just have the missing, the null value. So does it detect as a missing?
Sorry, could you come
so
again?
In SAS, yeah. In SAS, we have a numeric missing, right? Instead of NaN or NA.
Yeah.
If I have just missing, will it detect?
Just missing means what? Blank, right?
Yeah, blank.
Yeah. So you'll have to convert that either in the form of a numeric missing or a character missing, because it basically don't recognize the blank. Okay. For example,
we have a dot.
Dot is a numeric, right? So you can identify that with the NA. But here we don't have a possibility of dot. Why? Because we have these defined way, right? We can have 0 by infinity, that is also infinity. Why we get dot in SAS? There is only two possibility, right? Either it will not able to convert that values, right? The second thing is sometimes we'll have insufficient thing, right? That's why it will not able to evaluate, right? But here we should not have that situation. So if you are converting any data from SAS to R, it ideally converts this dot, right? Or into either numeric NAs, or so basically that dot is a numeric NA, so it will basically convert as NA, right? And if you have that structure, it can very easily detect. You cannot compare the SAS with R, right? You'll have to first convert into R, right? And then you can compare the structure. Okay?
Okay.
Yeah.
What if we, in the real data, we have like a lot of missing values and
the first thing, in case of missing. So if we are talking about the blank, right? Just say blank, right? So in case of blank, the first thing what we do if we are using the SAS data, right, in R, the first thing we'll convert all the blanks to NA, right? And then we'll perform the operation, the further evaluation and all, right? The first thing is we'll first convert all the blanks into NA using various functions. We have functions in admiral package that can very easily converts all the rows where we have missing, so where we have blank values, right, into either numeric NAs or character NAs based on the variables data type, right? And then we can perform the usual operations, because that is the first step. I'll show you maybe when I show you some extra class, right, at the very end after completion of part 2, I'll cover that function.
Do we also have assignments or practice something?
I'll give the assignment in the part 2 of the course. So in the part 1, the assignment is just do practice, right? Whatever the code chunk I'll provide, just try to just modify here and there and try to do the practice. We don't have any formal assignment. Why I have not added assignment, because we all are working, right? And sometimes we don't have a sufficient time, right, So if I add assignments, so maybe at the end I don't receive any answer, right? So because of availability of time, so that's why we don't have assignment. If you have time, you can just do a practice, right? You can search, you can you have books, right? You can just follow that as well. Okay. Yeah, please. Anybody?
Sir, if any records you download already
Sorry.
in my drive, I think in my drive I'm not getting any records.
Not getting any
Class records. Class records.
Okay, class recordings, right?
Yeah, records. Yeah.
Yeah. So you'll have to. Did you completed the fee? Pay the fee?
Yeah.
So you'll have to
Completed.
contact
Actually,
the course coordinator. You'll have to contact the course coordinator, and they will guide you how to access the portal, right? And then you can able to access all the material. For me, I just upload all the materials, recording and code chunk, right, on the drive, and they will basically provide you the access of the drive. Okay.
Yeah, I got SAS and all, but this one I don't know.
Yeah, so you'll have to contact. You can contact Supu or Balu.
Okay.
Yeah.
Okay, I will contact.
Okay.
Ranjit, I actually contacted Subbu. He
Mhm.
sent me the link, but I'm getting only the demo session.
Okay, so maybe you can follow with them because I don't have authority to share, right? So basically, the course coordinators share all the material. Yeah, because I don't have the sharing access. Okay. Any follow up question related to class? So if you don't have a number of Subbu, maybe just let me know. I'll just ping his number in the WhatsApp group. Maybe you can follow with them, or you can also contact Palu, right? And then I'll get the material. Okay. The next structure.
I have.
Sorry. Sorry.
I have his number. I will contact.
Okay.
him.
Yeah.
Thank you.
Yeah. That's good. Okay. Okay. So next thing is we can create a data frame. A data frame is basically a tabular structure of R. And the benefit is here we can do all kinds of physical modeling efficiently if we have a data frame. And the other thing is you can do a processing of data, right? Converting from unstructured data to a structured one very efficiently whenever we have a data frame, right? So that's why this concept is very useful, right? And unlike matrix, we can store different type of data type inside a data frame. Okay, so you can have numeric data, you can have character data, and so on. For example, here, how to create the data frame. Yesterday I covered. You'll have to use data.frame function, and then inside the parentheses, right, you'll have to first specify the variable name or column name. Yeah, and you can specify the values. So here I'm giving 1 colon 6. That means I want to store 6 values, and here we have the names, and here we have 6 name. Okay, the thing is here all the variables that we are specifying must have the same number of element. Okay, if you don't have, so you can add NAs and you can complete, otherwise it will give an error. And then we have function in rows and in calls that basically provides us the number of rows, right, or number of observations. So here if you notice we have the index 1 to 6, that means we have 6 rows. And it can also extract the number of columns. We just have 2 columns, one is ID and the second is name. Similarly, if you want to add another variable, we can add the variable of age. This is again yeah, please.
Yeah, sorry to interrupt you.
No,
so ID will come by default, or we have to create?
Yeah, we have to provide the values. You can use capital ID, right? So whatever the thing that you write, it will appear here. Okay. So this is the value that this is the value. This is the name of the column, right, or variable name. And then here we'll have to specify the values. Okay. And you can have an equal number of elements. So hope this makes sense.
Yeah.
Okay, perfect. So you'll have to, whatever the thing that you write, it will appear here. This is the simple. And then, for example, suppose I try to accommodate here 7 values, 7 names. So in that case, I'll have to add NA if you don't have the values for a particular ID, right? So you must have an equal number of thing, right? If you don't have, for example, if I remove that any at the end, right, and if I run this, what this does, it give an error. Okay, and it gives an error that number of rows and number of colors are not same, so implying differing number of rows. So that's why it is giving error and will not create the data frame. So you must have the same number of element in all the variables. And the thing is how we can extract the values. This is very simple. We just have to specify first the data frame name, dollar symbol, and the variable name if you want to extract any variable from a data frame. If you just write age, right, so it will not work. It will give an error. Yeah, it will give an error. Object is not found, because here, if you notice this global environment, we don't have any objects with the name age, right? So age is there, but inside this vector, inside this data frame X. So for that, we'll have to specify this data frame name, and then dollar symbol, then variable name. And this variable should be as per the data, because this is a case sensitive language, right? So be careful, otherwise it will give an error. For example, here if I show you this X, we have age where we have capital A. If I use here small a, right, age with a small a, so in that case it will give an error, because we don't have any columns, right, with the name age where we have capital A at the beginning. That's why it is giving null. So you'll have to be very careful while extracting the thing. Then again, you can extract the other values. Yeah, suppose you want to extract a particular thing, right? For example, I want to extract the fourth name, right? So you can specify big bracket 4 and you can extract that. Okay, then there is another way. You can use attach function, right, and you can extract the variable without specifying the data frame name. So this is the way of pulling all the variable inside this data frame, inside this global environment, using this attach. So if we activate that, what it does, it will basically bring all the variable that this data frame X contains, right, inside this global environment. And now you can very easily extract just specifying the name. You don't have to specify the data frame structure. I guess ID is not there. I just changed that with capital I and capital D. That's why I'll have to now update here as well. Yeah, now. Similarly,
Ranjit,
yes.
So for the data frame, so ID with a C of 1:6, 5. So instead of 1:6, we can also give 1:7, right? Instead
Correct,
of 1:6.
Yeah, correct. You can give 1:7. So why I did this way, right? Because if you notice in the beginning, right, I just used 6 values here and 6 names. I just want to, I added Ranjit at the end. I also, then I have to increase that. So how we can increase? We can use this one as it is, and I can add comma and 7. Or you can use 1:7. That's absolutely right. There is no issue. Okay?
Okay.
Yeah. Okay, so next thing is we can also extract the name, and suppose, so this is a simple way of extracting the object whenever you are working with the 1 or 2 data frame. But sometimes we'll have to work with a multiple data frame at the time, right? And in that case, I don't recommend this attach and detach way of extracting the variable, because it'll basically confuse. For example, there might be the case one variable is present in all 4 data frame, right, that you're working at the particular RStudio session. I'm not able to remember, right, which variable you're pulling. So that's why I don't recommend, but this is useful whenever you're working with a single data frame. Okay, then I can, if I detach that functionality, right, it will basically deactivate that function, and now I'm not able to extract the variable with a single name, right, with just a name, right. I'll not do that. Similarly, we can also extract the structure of this data frame X, right? This is again a data frame having 7 observations, 3 variable, right? And these are the 3 variable and their attributes. Okay. Similarly, you can create, for example, this age is stored as a character. What I can do, I can convert that into a character. So first of all, I can pull this way, right? And then I use as.numeric. This is a explicit coercion, and I can convert that into numeric data. And then I can store this whole thing with the name age underscore num. So what I have to do, I just have to do the assignment, and it will store inside this variable. Okay, so this is the variable we have here. Okay, suppose I want to add a variable in the data frame itself. So what I can do, I can use the same function here in the right hand side, but on the left hand side I just have to use additional structure, the x dollar symbol, the variable name, right? So in this way, what this does, it will basically add a variable with the name age underscore name under this data frame x, right? So this is the way how we can add extra column, right? Earlier we were just having these three, ID, name, and age, but now we have additional column age underscore num, and this is numeric. Okay, you can check the structure now. We'll have 4 variables. Okay, so this is the way how we can do it. The next part is the extracting or defining of names of any objects, right? Let me do that. For example, here we have ID. This is the values 1, 2, and 3. I can allocate the name for each values using the names function, right? I can use names and ID because here we have just 3 values, 1, 2, 3. I can give 3 name, right? It basically assign, right? As 1 as Ankit, 2 as Andrew, 3 as Zia. And now if I run this names function, it will give 3. So we are allocating the column names here. So you can do that for a particular values. Okay, here also in the case of list, so I'll just show you one different structure. So whenever I just gave very beginning, right, how we assign the variable name, and variable name should not have space, right? But here I'm giving a space, so that's why we'll have to add a quotation, right? This is variable name, and I'm assigning values as 1. The second variable name is Boston. Here we don't have space, that's why we don't have to use quotation, and I'm giving values as 2. Third is London, so this is a variable name, and I'm giving values 3. This is list structure. So if you notice the difference, the first one, Los Angeles, right? Here we have additional symbol. This is called tick symbol at the beginning and at the end. Why? Because we have a space. That's why we have the wrapper as a tick, just to make these two together, right? Because we have a space in between. So the problem with this structure is if I use the names, it'll give here the quotation with the space. This is okay, but suppose I want to extract this values 1. So what I can do, I can use the list name x dollar symbol, and then I have to use Los Angeles. And if you notice, every time we'll have to use this tick at the beginning and tick at the end. So this is the very complex structure, right? We should not follow these kinds of structure because we'll have to use tick at the beginning and tick at the end, right? And this is not an efficient way of giving the variable name, right? Or a column name. So instead of that, what you can do, and also, for example, you can do this way of extracting the variable, right? I already covered this one. So you can use this. So you'll have to use quotation every time. Or what you can do, you can define all together the variable name with either underscore or a period. And in that case, you'll not have a problem of specifying tick in the beginning at the end. For example, if I want to extract the 1, so what I can do, I can use this one and Los Angeles. And if you notice, we don't have the tick in the beginning and the end because we don't have a space or any other additional symbols, right? So whenever you are specifying the names, right, try to use structure, the meaningful structure, right, or the structure that R accept. R does not accept the space inside the variable name. R does not accept the other symbol other than underscore and dot. Okay, so this is the way. Similarly, we can also specify the names, right, the row names or column names for a matrix. Let me create a matrix of a 2 by 2, and here we can specify the names. So you can use dims names, right, for specifying the names. And here, because we have 2 structure, rows, 2 row, right, this is row number 1, this is row number 2, we have column number 1, column number 2, and I can specify here. I have to specify 4 values, so I can specify inside the list. These 2, right, is for the row, and these 2 is for the column. So let me do that. here. If you notice, AB is for the row. This is row number 1, row number 2. So whatever the value that you will specify, this is for row number 1, this is for row number 2, this is for column number 1, and this is for column number 2. Yeah, if you want to swap that, right, if you want to specify C and D as a row number, row name, so you can change, right, and it'll basically assign in a different way. So now C and D as a row here, and A and B as a column. Okay, you can specify explicit. So whenever you are specifying dim names, whenever you are using dim name as a function, you'll have to provide as a list, right? But you can also use call names, and you can specify the column name here. So I can give H and F for the column. Here we have, and I can also give row names X and Z. So here, this is the object. But I'll recommend don't use these ad hoc symbols or ad hoc alphabets. Try to use some meaningful names. That means for the column names, try to use a prefix as call, and then you can use _1 for the first column, _2 for the second column, and so on. For the third, you can use _3 as a suffix, right? These are the meaningful name, right? Because anyone can understand that these are the column, right? Column 1, column 2. Similarly, we can specify row name as row 1 and row 2. Right? These are a meaningful name. And once I run this attribute function, now it'll give a whole lot of information. It'll give first the dimension. Yeah, if you notice at the beginning, I showed this attribute function here. If I run this attribute function here, it just give a dimension, number of rows, number of columns. But on the other hand, after specifying these rows and columns, so we'll have a whole lot of let me run this again. Oh. Okay, I guess it has updated that part. That's why it is not giving. Yeah. Okay, let me just run this matrix M first. This is the matrix, and now I can specify the column name. Oh, sorry. Now we have here a different matrix. That's why, because I just used the same name, this way it is creating a problem. Okay, let me run this again, this matrix M. Now we have 2 rows and 2 columns. Why is this giving an error? Because in the original, right, at the top, I specify matrix with 3 columns and 3 rows, so I'll have 2. If I want to use this one, so I'll have to specify here additional column and additional row, right? But when I use this matrix 2 by 2 matrix, it works very well with this row 1 and row 2 and column 1 and column 2. If I use attribute function, it will give here first dimension, number of rows and number of columns. It also gives here the dimension, right? And also the row names, row 1, row 2, column names, column 1, column 2. Okay, so these are the things I just want to cover in this session. I'll pause here. Any question, anybody?
Hi, sir. So if we want to check the column name of a one data frame, like how many variables are there in a data frame, so
you can
call
use
name will work.
Yeah, call names works. You can use call names. Yeah, and you can use a data frame. For example, I created X as a data frame. Oh, sorry. Okay, let me run, because as this is the problem, I generally use same object name, right, again and again. That's why it is basically. So here we have X as is a data frame, and now I can use call names. Let me use here so that you can replicate at your end. It will give here the variable name or column name, ID names. We can also use names. It will give same answer. Yeah.
And if we want to check how many observations are there, then
yeah, so you can use here maybe give me a second. You can use n rows. Seven. Or in the same statement, you can use just a dim. Yeah, dim. I'll give 7 rows. That means we have 7 records or 7 observations, and we have 3 variables. And you can go further down and you can extract the variable name using either this names function or call names function. Yeah.
And call will also work, like and call.
Yeah, n call basically extract the number of columns. Yeah, but it will not extract the names.
Yeah, and on the column.
Correct. Yeah.
Okay. Thank you.
Perfect. Anybody, any question, thoughts? So I just want to ask everyone, right? So maybe, yeah. Yes, Razi. Because someone is speaking. Maybe you can go. I can just continue. Yeah.
Yeah, can we extract rows like we are extracting column wise, right? So can we extract row
Yeah, you
in
can.
the data frame?
You don't have the, because here the problem with the, for example, if I show this X, so here we have the rows, right? It basically have as a additional structure. It can give a number, right? But you cannot extract that. I'll show you later a function where we can convert these rows at additional column. In SAS, it basically have underscore n underscore. Here we have a functions rows to name. That is a part of dplyr package, right? We can use that. We convert additional column or additional variable where we are just dumping these values 1 to 7. But we cannot extract that explicitly without using any other function. I am not able to recall exactly right now. Okay. Okay, so that's all for the day.